Okay, so I'm going to do a problem that arises in trigonometric trig substitutions. So the problem is we have an integral of 1 over square root of 30x minus x squared dx. And we know how to solve, for example, we know how to solve integrals like this, where a is just a constant. But now, this is no longer, 30x is not a constant, it depends on x now. So, and they look similar, so we want to try to use these trigonometric substitutions. So what I'll first do is just rewrite the denominator. I'll just I'll factor out a negative 1. So we'll get x squared minus 30x. Close that. And what I want to do is complete the square for this to get it in terms of something like this. So to complete the square, we have a negative. We're going to have to, we keep our x squared minus 30x. And to complete the square, we have to add and subtract 15 squared. So that's 225. So that's what we have, dx. So we haven't changed anything, right? We just added and subtracted 225. And now we have to notice that this can be factorized. So this part, we have an x minus a 15 squared. That's these three terms. And then you'll get a plus 225 dx. Right, so now this is written as in this form, where 225 is just 15 squared. So now we're in good shape. I'll just rewrite this so it's very obvious. That's in that form. So we get square root of 225 minus x minus 15 squared dx. Okay, so now we're ready to use our trigonometric substitutions. To do that, so we have this triangle, a right angle, and we pick some theta here. So because we have this form a squared minus some variable squared, we know that this number will be on the hypotenuse. So the square root of 225 is 15. And here, there's two choices of where to put x minus 15. We could put it here, or we could put it here. So the good choice is to put it over here, x minus 15. And then so by the Pythagorean theorem, we have to have that this is 225 minus x minus 15 squared. Right. And now we can use our trig substitution. We let sine theta be opposite over hypotenuse. So I'll just multiply both sides by 15. And now we can take the derivative of this. So this is 15 cosine theta d theta equals dx. So we have our dx, and now we need to write what this is. Well, this we can just use secant. Secant theta will be, I don't want to use secant. I want to use cosine. Cosine theta will be adjacent 225 minus x minus 15 squared divided by hypotenuse, which is 15, so I'll just put it over here, multiplying both sides by 15. So we use this, and we use this to our integral now. Okay, so dx, 15 cosine theta d theta over over t cosine theta. Which is equal to just involve theta, d theta, which is just equal to equal to 1, which is equal to theta. I think I made a mistake.
Okay.
Oh.